Okay, so this is word break. This is string that we want to make sure if this can be constructed into word break. Okay, let's see. Let me write some pseudocode first. So we first need to transfer this dictionary into a hash map. So then we can search that by word by word. And this is also we need to kind of like scan the screen to making sure this is to making sure each word can be find. But the thing is, where we screen this, for example, if this is a BBC, we could have different way to kind of like construct the word if like these are the first word and this is the second word. So I imagine we probably need sort of like a backtrack to making sure the uh, the we can reach the um, end of the pointer to the string, right? So with that said, we also need to consider the corner cases, which is now. Then, um, okay, let's maybe start to kind of like write a little bit. Then we can like improve this traverse logic, traceback logic. So if hmm, what we need is mm, Mm, okay, so what to say? I don't think we. Okay, I'm just thinking if we should use like a for loop to loop this, and then we do a traverse, or we just traverse itself, right? So um, then set speed. Okay, and we do start. Uh, and mm, mm, Okay, so what I did is normal case looks good, right? So this is the case for the screen 342334. So it should be, so if there's a one returned as true, then it should return is valid. Okay. Then I just return, but no. So this return was early, right? Okay. If this is true, then I return true, else return false. Okay, that seems fast, but this one is a bit interesting. Okay. Mm, high exist exit high limit exceeded. Okay, so this means we probably like checking a lot, but we are not checking this guy. So maybe we need to, okay, that's mm, um, the complexity of this one is, oh, this goes to n, then in each one we look at that traverse. So it's on times n inside this, so it's n squared. So can we do better, right? So this one is on times o squared. It's not ideal. Okay, so interesting. Um, okay. Um, it's already been 60 minutes. Let me make actually check the solution. Um, then I will change this. I think maybe there's another way to improve this, but um, okay, so looks like we have memorization. or DP, but maybe the memorization is better. Um, right. So if say if any part of the substring is already calculated, then we should memorize that, right? So okay, so memorization is memo, then uh okay, so if we know, okay, so mm, so if we know this, this will be like 0 to 5, 1 to 5, 6 to 5. If we know it's true, then we set the memorization. So okay, so let's see. Hmm, Boolean memorization equals to new Boolean. Then this is, let's see, a string has n size. I want to know the last n, the um last uh n is valid or not, right? So that means the last 0 plus n characters. So I want to do this one is last size uh, I element is valid or not, right? So if that's the case, I also need to add memo into my input, and where this is true, then I need to set memo. This is end, so that means end minus uh minus start. So that's equals to true. And if memo and minus start is true, no. So this means the end is never changed. So return true, right? So that means only start is changing. So this should be safe. Okay. Memorization. Okay, something is not right. Okay, so start from 0. Start. I should do this. start from okay. Why? Okay, so the trick in here is looks like they have three steps. Is not not used. I mean, sorry, not is now all tested, right? So in here, I want to make sure. Hmm, interesting. So this is Boolean, right? So then this is now can be object, can be a noun. Let's see. Okay, so this works. Um, what's the time complexity on this? So I think it's still, oh, oh, I think it's still O square because oh, for each one, it's for this one, there's on then on, so it's on square. For this one, do I need to do the DP? Probably yes, but hmm, okay. Let me actually think one thing. In here, start from I, right? The first I. So actually, this is start, so this should be able to also pass that, right? Yes. So okay. So this is memorization. Okay, good memorization. Mm, can can be now true or false. Okay, so now let's think a little bit about DP. I haven't checked the solution yet, but uh, okay, so hmm, let's think a little bit. So DP is we can do DP means first I elements can be valid, then expand to n, right? Of course, we have some corner cases. So, okay, so let's do this. Boolean of BP is new Boolean and dot length and uh, word dictionary, right? So let's see. This is the first n elements, so can be n plus one. So if they are zero, right? So dp0 is uh, that. Then the transformation function is dpi equals to dpi minus uh like words word, right? For each word we can do that. Then this is a word. dp if this is a word, right? So if word x in dictionary, okay. So then the answer can be let's see, for DP normally we like to increase the I. So for int I equals to 0, I minus n plus 1, I plus plus, then for let's see the string word in that, right? So for each one, dpi equals dpi equals dpi minus this, right? So int length equals to word dot length. So if I so this is current words there if oh so see so first n characters, right? So if I minus n greater or equals to 0, then we can do this. Right. So in this case, we just need to return dp n plus 1. So this is the first dp0 equals to true. So the first length, the first I minus n character plus I, so the first character, right? So let's see. Okay. That's out of bound for this form. So, oh, sorry. This is the last one is dpn, right? Okay, something is not. Okay, maybe this is not. Um, hmm, okay. So let's see if this transform function is correct. So, this means this guy contains the first I character. Let's see the first uh 9, then the first last 4. I don't see an issue in here. So this is correct, but this is wrong. This is also wrong. So oh, this is right. This is wrong. Expected true, but output is false. Hmm. Start and okay. Okay, at this point, I think it's already past 30 minutes. I need to ask, look at the answer. Why covered the oh, shoot. If API minus length is true, only if this, then I just cover that. Otherwise, I don't want to cover that, right? So, okay. So see. Hmm. Ah, another thing I think I missed is I didn't compare the words with this, right? So word match. So basically is word equals um the first I characters. The first okay, so this is actually the first I characters, right? So that means the first, let's say 9 minus 4 equals first I characters equals to, right? So this is, let's say if I goes to this one, end of the character in here, the first uh, 9 minus 4 is 5. So this is 5. Then this is first I characters that equals to this. And so that means I also want to making sure this is a match. Okay, this can go to Okay, this should go to here. Okay, so this is also m times n. So this is oh, did I stop recording?